In the previous video, we saw a number of sequence types. We saw what a range is, what a list is, what a string is, and what a tuple is. Remember. Alright, so the range can be used using r equal to range 1 to 10. List is just say x within square brackets 1, 2, 3. A string is essentially just a standard string within single quotes or double quotes. A tuple is indicated within parentheses, and basically a tuple can have elements of different types. And there are a number of operations that you can perform on these sequences. You can index them. So r of I gives you the ith element of the sequence. So you can slice. So r of I to j gives you returns all the elements from the ith location to the j minus 1th location. Concatenation, the plus operator basically is overloaded, and therefore you can concatenate two sequences using the plus operator. You can also say 2 times r or 2 times x will give you concatenation of x with itself 2 times. That's a product operator. There are some other operations that you can do on strings or on these sequences. Basically, these operators or these operations behave the same way, irrespective of whether you're operating on a range or a list or a string or a tuple. So, for example, as we've seen previously, when I use the for loop, I can say for I in range 1, 10. Right? Print I. So this will just print all the elements from 1 up to 9. Now I have declared r equal to range of 1 to 10, which means that I can also say r for I in range r, print I, and this will return the same thing. Right? So it gives me the same thing. Right? So that's a subtle point, but an important point to keep in mind. When you're using a for loop, essentially you're iterating over elements in some kind of a sequence. Unlike C, when you say for say I equal to 0, I less than 10, I plus plus. In C, what is internally happening is that it's declaring an integer. You have an integer type, an integer variable I. It takes the value of 0, and in every loop you're increasing I by 1. Whereas in a for loop in Python, essentially you're creating this entire structure. It's a sequence, right? So this sequence R, when you say for I in range 1, 1000, you're actually creating a sequence of length 1000, and that is stored on disk. And that is why for loops are not very efficient in that sense. All right, and that's an important point to keep in mind. So as much as possible, you should try to avoid using for loops. There are, of course, situations where you're forced to use for loops, and sometimes we don't really care. But really, if speed and performance are important to you, then you should avoid using for loops as much as possible, right? Because it takes a lot of memory. All right, so that's point number 1. Another point is that when you say I in range, what Python is essentially doing is it's varying, it's looping I through in this particular array. So for example, I can do for I in R. Remember that R was declared to be range of 1, 10. It basically printed 1 up to 9. Now I can say for I in X, right? So X is a list, and that will print the elements of X. I can also say for I in S, right? And it's going to basically loop through the elements, the individual characters of this string. And similarly for the tuple as well. So T, right? 1A2. So that's a useful point to note. So for example, when you're writing for loops in some cases, you may want to just use this in this particular fashion rather than say indexing. So for example, if you had to do something similar in C, it would look a lot more cumbersome, right? But this I in T, just this sequence of operations, that's a very useful thing and can be used in many different ways. So for example, suppose I want to get the square of all the elements in R. All right, so I want basically 1 square, 2 square, 3 square, 4 square, up to 10 square. Right, so I could do it in the following way for print. So I star star 2 is basically I raised to the exponent 2. I cube would be I star star 3, and so on. Right, so double asterisk basically denotes exponentiation. There's a more convenient way. Suppose I want an array with all the elements squared, then I can declare it in the following way. I square for I in a range 1 to 10. Or I can say, since I already have a variable r which basically does the same thing, I square for I in r is going to give me square array, and I can print square array. Right, so that gives me 1, 4, 9, 16, 25. So basically all the elements squared. But this gets a lot more interesting if you have other things. So for example, suppose I have let's say S, the string, right? So the string is basically a character string, string. Now suppose I do I square for I in S. Okay, sorry, so this doesn't work, but I can do a 2 times I, right? That gives me SSTTRRIINNGG. So these are, again, uh, at times this may not seem so useful at the moment, but just knowing that these features are available in Python can save a lot of time, and you can in general code much better, right? You can do the same thing for the tuple as well. So right, so 2AA4. So remember that, so note that I used 2 times I. So since the first element was an integer, it multiplied by 2. The third element was an integer, so it multiplied by 4. The second element was a character, and therefore, or in other words, a string. Therefore, it just concatenated the string with itself. All right, so these are useful points to keep in mind. But also I can use this for I in T in many different ways. So suppose I want to check if my array has a particular element. So let's say I declare element equal to the character A. Right, I want to check if a particular array or if a particular tuple contains this particular element. So I can say if element in the R, I want to know if the sequence R contains the element A. I can print element present. Right, so in this case it's not present. I can do the same in the string. Element is not present. But now I can run it through the tuple. Right, the tuple, remember, is 1A2, so the tuple does contain the element A, and voila, the element is present. Right, so these are useful things to know. Instead of creating a for loop and checking if the element is present, you can just say if element in T, print element present. So these are nice features about Python, which help you write cleaner code. Right, I can do the same thing. If element not in T, you can say element absent. So the element is present in T. Then if I do it for S, element is absent, right? So these are additional operations that you can perform on sequences. Now, the sequences are, as I mentioned, there are all of these operations that you can perform on any of these sequences. It can be either a range or a list or a string or a tuple, but all of these types are not the same. There's one feature which distinguishes the list from the others. From the list from particularly the tuple or the range, and that is in terms of mutability. Now I have R, which is a range, right? Suppose I want to change one element of R. So I want to say that R of 1 should be equal to 4, right? I can't do that because it does not support reassignment of elements. Uh, but can I do it on a string? It does not support. So all of these objects do not support the string or the range or the a tuple. These do not support reassignment. So for example, I can take T. It doesn't do it. This is not a permitted operation. But on the other hand, if I take the array, right? So the list that I had, the list was X. So I can try X of 1 equal to R. Print X, and that would be the following list 1R3. So the list is mutable, but the other sequences, the tuple, the string, and the range are immutable. And R of 1. So this is a property which is unique to a list. So you can reassign values to certain elements of a list, but you cannot do it for the other types of sequences. All right. So here's also a subtle point to keep in mind, particularly related to data types. So this is a feature which is different in Python compared to C or C++, and that is that all of these things that we're declaring, right? So when I say I equal to 2, this I is in fact, so this 2 is in fact an object. We are not declaring that I is of a certain data type, right? So I can say I equal to 2, print I. So right now, the variable I is assigned to the object 2. It's a label to this particular object, which is an integer 2. But immediately I can say that I is equal to hello, which is of completely different type, right? So unlike C or C++, where you first had to declare a particular variable, and when you declare a variable, the compiler assigns a certain chunk of memory to it, and then you can manipulate that particular memory. Here, essentially, when you say 2, it is creating uh, a chunk of memory where it's stored, where the Python interpreter is storing 2, and this 2 is assigned the value or a label of I. Now, why is this important? This is important because when you declare two different variables, it can have unintended consequences. So let's say that I have array 1 equal to 1 comma 2 comma 3, and arr2 equal to arr1, right? Let's print arr1 and print arr2. Okay, so both of them have essentially the same content. Now, Let me say that ARR1 of 1 is equal to 4, right? Now let's print ARR1 and print ARR2. So I only changed the second element of ARR1, right? But I see that even the second element of ARR2 has changed. So that's a very important point to keep in mind whenever you're writing code in Python. When you say ARR1 equal to ARR2 equal to ARR1, it does not create a copy of ARR1 and store it in ARR2. Essentially, there is only one array, and that is 1, 2, 3. And ARR1 and ARR2 are basically labels to this array. So both of them are pointing to the same chunk of memory. And that is extremely important to keep in mind. Otherwise, you can have a really bad bug in your code. So if you want to create a separate copy, you typically do something like copy, right? And now if I do ARR1 of equal to 4, then ARR2 still is 1, 2, 3, because ARR2 is a copy of ARR1. It is not equal to ARR1. Right? So this is a very important point to keep in mind.